here we have enthalpy change. So let's see how it's defined. So enthalpy change, enthalpy change is amount of energy or heat absorbed or released during a chemical reaction under constant pressure. So enthalpy change enthalpy change is amount of heat absorbed or released during a chemical reaction under constant pressure. So from here we can now proceed to the next objective. So understand the need for standard. The keyword is here standard enthalpies, and be able to define standard enthalpy. So let's move on. So to the worldwide, we must have same enthalpy change for to everywhere. So in order to measure enthalpy, so we must have standard conditions. So in chemistry, standard conditions are very important. So standard conditions is, first of all, temperature must be room temperature, or room degree, or say 25 degrees, 298 Kelvin. And pressure, we said that we had constant pressure, so pressure must be at normal pressure, atmospheric. And if we have solutions, so any solutions involved in this enthalpies, this solution must be in 1 molar concentration. So 1 molar concentration. So this, when we apply these conditions, so temperature 25 degrees, pressure 1 atmosphere, and solution, if we have solutions of 1 molar solution, then our enthalpy change, which is measured under these conditions, is called standard enthalpy change. So in order to have standard enthalpy change, you must have these conditions. So this leads to standard enthalpy change. So there are different standard enthalpy changes, more than 10 actually. So here we talk about standard enthalpy change. So now let's talk about types of standard enthalpy change. First one is enthalpy change for formation. So as it says, formation. So you guys should memorize all these definitions for enthalpies. So first of all is formation. Formation says that enthalpy change released or absorbed. So mostly formation is mostly exothermic. Released, so energy released when energy released when 1 mole of substance is formed, so formation, formed from its elements in their standard states. So why standard states? Because gas at room temperature, so at 25 degrees, is standard state. For example, so energy released when 1 mole of substance is formed from its elements in their standard state. For example, the reaction, formation of water. So let's say water. H2O is formed by hydrogen reacting with oxygen. So by the definition, we know that 1 mole of substance is formed. Yeah. So we must have here 1. So to get 1 mole of water, here we need to put 1.5, 1 over 2 oxygen. So in order to get 1 mole of water. So this is, if I remember, is 2 minus 286 kilojoule per mole. So formation, when 1 mole of substance is formed from its elements in their standard states. So we can write states. Hydrogen is gas at room temperature, oxygen is gas, and here we say at room temperature is liquid. So this is first one. One of the important enthalpy changes. So you guys need to memorize this. Formation. Now let's move on the second one. So one of the most important, combustion. So this is always exothermic, always exo. Combustion. So energy released when again 1 mole of substance undergoes complete combustion. Again under standard conditions. So example, let's say carbon reacting with oxygen. So here we are forming carbon dioxide. So carbon at standard state is solid, so mostly graphite, coil. Oxygen is gas, carbon dioxide is also gas. So this enthalpy is called combustion enthalpy. When we burn 1 mole of substance. So here we have 1 mole of carbon. Next enthalpy change is called atomization. For you don't need to memorize this because this is also important in examinations, but for now you don't need to memorize atomization. But in the next term, in the next units, you need to use this atomization, enthalpy change for atomization. For example, in Hess cycle. So atomization is always endothermic. So atomization is energy required to form 1 mole of atom. Energy required to form 1 mole of atom from its element, we can say from its molecule, and so on, from its elements or molecule. So energy required to form 1 mole of atom from its elements. So example here, we say that sodium solid at under standard conditions is solid. So when we give some energy, when we heat this solid sodium, we get gaseous sodium. Another case, we have chlorine molecule, which is gas. We get here chlorine atom. So again, by definition, we must form 1 mole of atom. So here on the left side, as we have 2 chlorine or chlorine molecule, we need to put 1 divided by 2. So to balance this reaction. So this is atomization enthalpies. Enthalpy change for the atomization. Next, so number 4 is solution. So least important. So solution is just energy released when again 1 mole of, in this case, ionic solid is dissolved in water. So remember, when salt dissolves in water, it releases some kind of energy actually, but we need also some energy to break ionic lattice structure of this salt. So solution. Next one, hydration. So a little bit same, but in hydration where it involves gases, energy released when 1 mole of gaseous ion is dissolved in water. So least important also hydration and solution. And next one, for now least important, but it will be important next semesters. So lattice energy. Lattice energy. So it divides into two. First of all, formation, or dissociation. Formation or dissociation. So by the name formations, so obvious that energy released when something is formed. Dissociation, energy required to dissociate something. So by its name, it's lattice. Formation, energy released when 1 mole of ionic lattice is formed. And dissociation, so energy required, so to break bonds you require energy when 1 mole of ionic lattice is dissociated or broken. Okay, so this is lattice energy. Next one, sublimation. Sublimation is exactly the same with sublimation. So exactly the same with atomization. sublimation. But in some cases, gaseous molecules you don't need to sublime. So sublimation is used for solid substance. Sublimation. So here we have solid sodium. Energy required to sublime this solid sodium. Okay, so we form sodium in gaseous state. Next one, ionization. So ionization, guys, you know the definition. Okay, ionization. So energy required to take out 1 mole of electron from 1 mole of gaseous atom to form unipositive gaseous ion. And we have electron affinity, which is completely opposite to ionization. So ionization means energy required to take out 1 mole of electron, but in the case of electron affinity, is energy released when 1 mole of electron is absorbed or taken by the atom. So when atom gets this 1 mole of electron, it releases some energy. Okay, so electron affinity. And one of the last, neutralization. Energy released or absorbed when 1 mole of water molecule is formed. 1 mole of water molecule. So if you have any questions, you can ask from your teachers to explain further.